And I know this for a fact. Some departments or some other universities, they say it's exactly the same thing. No, it's not exactly the same thing. It is not exactly the same thing. The position can be sometimes be the same, but sometimes it can be different. And I want you all to know the difference. Okay, we cannot say no, it's the same. It's different. Okay, so centroid is based on geometry. Okay, so by finding centroid, you just find based on geometry. Whereas the neutral axis is based on stress x is equal to 0. So very different. Okay, one is a geometric you acquire based on geometry. The other one you based on what? Stress field. Okay, so now so there are condition where the centroid and neutral axis are the same position or on the same line. But there are also stages where they are not the same. Okay, so position of the centroid and neutral axis okay are the same only okay only for centric symmetrical bending. Okay, only the same that. So what do I mean by that? Okay, so we are talking about the position. I'm going to highlight the position. Okay, so now let's say we have a structure now. Okay, and we are going to view this in the cross-section view. Okay, we're going to view this in the cross-section view. Okay, so this is our cross-section view, and this is the position of our centroid. Good. Okay, so this is our centroid. And I'm going to call this or Y or Z. Well, this is rotation about X. Okay, so from here, we have a moment vector. So we have compression, and you have what? Tensor. So now we are going to sketch. Okay, we're going to sketch the normal stress distribution. Okay, so now on the x-axis now, this is your normal stress in the x direction. And over here, This is your y. Okay. So if we know that the top, so this is 0 for sure. Anything on the right hand side is in tensile. Anything on the left hand side is compression. Okay, so stress X is negative on this side, stress X is positive on the other side. So I'm going to sketch now. Okay, sketch now the formula. We're going to sketch the formula where we have stress X is equal to minus mz over izz multiplied by y. So we know that anything when on top of our centroid, right, is 0, okay, or is in compression. So this is how our stress distribution will look like. This is how our stress distribution will look like. Okay. So we know that over here, this is minus mz over izz multiplied by y. Whereas over here, this is positive mz over izz multiplied by y. Okay. So when the normal store over here, when the normal stress is equal to 0, this line is also known as the neutral axis. So if you look at the position of the centroid and the neutral axis, they are aligned on the same line. Can you see they are aligned? I'll use a different color. They are aligned. The position is exactly the same, and I'll use a thicker line. Okay, the position is exactly on this line. Okay, so this line is where what? The centroid and the neutral axis are on the same line. Okay. So it's only true when we have what? This is only true if we have centric symmetrical bending. Okay. So now I'm going to change it now, not too complicated, but in a simpler manner. And this simpler manner that we are going to change is we are now going to sketch the stress. Well, but before we sketch, there's something I forgot. Okay. Now, if we were to sketch the neutral or the stress distribution, we have arrows. So when it's in a compression, the arrow will push towards y. Okay, because the y over here, this line over here, okay, this line over here that I'm highlighting now, is like the material phase. Okay, so this is also the material phase, the phase of the material. So when it is in tensile, okay, it will travel from the material phase pulling away, right? So the pulling away is in tensile. So the pushing towards, right? So for this case, is pushing towards is compression. So that's how you sketch the stress distribution. Okay. So the next thing that I want to highlight is this. Okay. So now, what if now our structure is under eccentric symmetrical extending. Okay, I don't want to go into unsymmetrical. Okay, let's look at symmetrical, because it's only one condition where the centroid and the neutral axis on the same line. The rest, it will not be on the same line at all. Okay, that's where we have to be crystal clear about this. Okay, so let's look at the next condition now. Okay, so again, we are going to have our structure that's under eccentric symmetrical. So now we're going to draw again the box. Hey, box, not circle, Eugene. Come on. So 3 and 4. So the same. Right? So again, now, based on observation, this is the position of our centroid. Okay, so this is the position of our centroid. So this is our Y. And this is our Z. So in under eccentric, right, we know that stress X is equal, so we're going to assume Px over A minus by mz over izz multiplied by y. So I'm still going to put in the vector, right? This is my moment about z, right hand rule again, compression, and over here is tensile. Okay, so I'm going to sketch two graphs now, or three altogether. So the first graph that I'm going to sketch, right, so this is the first graph I'm going to sketch. And then we have our right. So the first line I'm going to draw is a straight line. And then let me make sure that the straight line. And this is our px over a. Okay, so it's in tension, right? Then the next line I'm going to draw, or the next graph that I'm going to sketch. So again, I think I have enough space. And then we had draw y and stress x. And because it is compression at the top, so I'm going to sketch our distribution. So this is how our distribution look like. Okay. So compression 0, and then go to tensile. So now if we add these two graphs, or we superposition them, right? So this one, the function is stress x is equal to minus mz over izz multiplied by y. And then when you add the both of them together, so I'm going to draw, now it has to be bigger, big. And then this is our y. shift it slightly over here. Right? So this is our Y, this is our stress Z, or X, not stress Z. This is our stress X. Right? So when you add the both of them, now your graph shift by 2. Right? Or shift. Right? So now this is the compression. Let me undo. I'll use red. So now this is now the compression part. And then 0, then it go into what? Tensile. Can you all see that? So when that's the case, this is now the position of our neutral axis. So I'm going to draw a straight line, right? I'm going to start from here, right? This is the position of our what? This is the position of our neutral axis, where stress X is equal to what? Is equal to 0, right? So the common thing about these two diagrams, the common thing about these two diagrams over here, one diagram here, one diagram here, right, is the y-axis are in the same orientation.